Hello there. Today I'll show you a simple way of making nitric acid. Nitric acid is a very useful chemical that, that can often be quite hard to get. Now, what is the reason for that, you might ask? Well, my dear viewer, we have two types of people to thank for this.
I'm gonna drive a cab, only got 20 bombs in my pocket.
With this out of the way, let's talk safety. This little process requires and produces a number of toxic and corrosive chemicals. To safely handle this kind of spice, I will be using gloves, a lab coat, and a gas mask with an appropriate filter. There is a number of ways to make nitric acid. This is my take on oxalic precipitation method. The idea is to take a common ammonium nitrate based fertilizer, convert it to calcium nitrate, and react it with oxalic acid to make nitric acid. To do this, I first dissolved 12.5 grams of the fertilizer in 100 milliliters of distilled water. Then I added 4.6 grams of lime. That is, for all intents and purposes, basically technical grade calcium hydroxide. This reaction makes calcium nitrate and ammonia gas. This is when the gas mask comes in handy. To get the reaction going and to drive the ammonia from the solution, I boil the reaction mix for an hour. If you can get calcium nitrate fertilizer, you are more than welcome to skip this step. In fact, I highly recommend you do. High temperature is required to speed up the reaction, and it also removes ammonia from the solution because gases have a lower solubility in warmer water. Once I prepare the calcium nitrate, I weighed out 5.6 grams of oxalic acid and dissolved it in 100 milliliters of hot distilled water. Once I prepared the solutions, I measured their pH. Solution of calcium nitrate had a pH of 8, meaning it was slightly basic. There was some leftover calcium hydroxide. Slight excess of calcium ions is good. It helps to ensure there is no leftover oxalic acid in the end product. Unlike calcium and nitrate ions, oxalic acid in nitric acid would be quite problematic because it would react with random metallic ions and create all kinds of mess. As expected, oxalic acid was strongly acidic with a pH of 2. Then I combined the dissolved oxalic acid with the filtered solution of calcium nitrate. The dissolved chemicals reacted, forming white calcium oxalate, which precipitated out of the solution, and nitric acid that stayed dissolved. Once oxalate settled to the bottom of the beaker, I poured off a bit of the solution into a vial with a piece of copper wire, and I measured the pH. There was no immediate reaction with copper, but the pH strip showed me the value of 1. I made some acid, but it was quite dilute. To prove it, I dissolved silver out of this big ceramic component. I simply placed it into a beaker, poured on some of the solution, and left it over the night. Next morning I had a clear indication my process worked. Nitric acid removed the silver from the ceramic and dissolved a bit of copper, turning the solution blue. Thank you for watching. See you next week.